Kia ora guys, sorry this is attempt 2 at making a video for piecewise functions and an introduction to limits. Piecewise functions. A piecewise function is a function with different graphs on it at the same time that would form a particular function to explain something. For example, Talia there is just a linear function, but Matt is a piecewise function. He is a combination of 3 different functions. So if I was to write his function, I would have to say, so the function equals 30 when x is between 0 and 3. It is 40 between 3 and 4, and 50 between 4 and 5. Okay, so that's how you would sort of write one of these piecewise functions. But how does it work if I'm saying he's between 3 and there? Like if he works 3 hours, how much does he get paid? I suppose he gets paid that much. The solid dot means it includes. Okay, the hollow dot means excludes. So to change these graphs around a little bit, or to change these equations, that should be less than or equal, when x is greater than or equal to 3 and greater than or equal to 4. So that's what the piecewise function would look like. 1.5 hours work, Matt gets $30. 3 hours work, it's $40. That's the key thing there. Okay. So what we're going on to here is we're going to have a little talk about limits. Okay, so we have a quick introduction to limits when you're talking about what's that called? Differentiation from first principles. Okay, but the limit of a function. Okay, so the limit of a function as x tends to a, so that's how it's written, is the value of the function as it gets closer and closer and closer and closer to a. Okay, so the graph x squared minus 4 x minus 2. So if I say that function is this, okay, are we happy with that graph? Because that's what Desmos plugged out. Hopefully you realize that in actual fact x cannot equal 2 here, and so what it would actually need is we'd need a hollow dot because it would exclude that particular value. And so here the limit as x tends to 2 of this function is 4. However, the function of 2 does not equal 4. In fact, it does not exist because of this hollow dot, this excluding dot. Okay, so a function tells you how a function, well, what it is at a point. A limit tells you how a function behaves near a point. Alright, so there are a couple of examples. Okay, so for a function to have a limit as x tends to a, it must be the same as it tends to from above or below. Like tending from below, for example, as the limit as x tends to 1, that's what we're doing. So as I get closer and closer and closer to 1 from below, okay, I get closer and closer to 0. The function gets closer and closer to 0 from below. From above, it gets closer and closer to 0. Therefore, the limit as x tends to 1 of the function is 0. But the function of 1 is actually 2 because it's that solid dot. Okay. Another example here. Oh, and what we do here, sorry, is if I put my finger on the far left and far right of the purple and the orange lines, and I scroll up with my fingers on the lines to that one point, because my fingers would touch, that's why there is a function. Okay, so I suppose we need to know when there is not a function, and here is a couple of occasions. So here is another piecewise function. Okay, as you can see, the blue, the red and the green lines. What is the limit of the function as x tends to -2? Okay, so from below, there is actually no, it doesn't actually get closer because there is no function here. So that means there is no function. So there is no limit. That's case 3. Case 2, case 1 actually, what about the limit as x tends to 2 of the function? Well, from above, it tends towards the value of 2. From below, it tends to the value of 4. So again, use my fingers. If I track along those lines, my fingers would not touch. So this means there is no limit. Okay. Use the finger test. Run your finger along the function from above and below. If they meet the same point, then you have a function. If not, there is not. And again, here, which is similar to the first one I just did, then from above, the limit as x tends towards 0 of this function does not exist. Why? Because the function does not exist less than 0. Okay, so I suppose the key thing here is what is a limit? Okay, but the key thing is, when is there no limit? Okay, there are no limit in these 3 cases. Case 1, when there is a jump, and there's a jump in the function. Why is that? It's because as my function approaches 2 from below, the function approaches 2 here. As the function approaches 2 from above, it approaches 3. Because these numbers do not match up, there is no limit. Okay, case 2 is sort of similar to case 3 in a way. Okay, because from above, from below, although they might approach the same number, since there is a gap here, it's like the function has ended, and therefore there is no limit because it does not follow that finger test. Can I run my finger along the limit or along the function from above and from below, and do you get the same number? The reason why we're going through this stuff is yeah, I mean, there are lots of different exam questions, and if I look through here, there's 2013, 14, 15, 16, 17, 18, you probably get the gist. There's going to be a question like this, and this is a really good way of making sure you know what you're doing. Okay, so I suppose the questions that you get asked are what's the limit, what's the value, is it differentiable, where does the gradient equal to 0, and where is the second derivative less than 0. And what they're really referring to is the next few exercises, next few activities, which is, where is my graph continuous or not? Where is it differentiable or not? These are the things you need to know. Where is there a limit and no limit, and about the concavity of the graph. Okay, so that's what you need to be able to do. If I was to ask you, question 3 down here. The limit as x tends to 3 of the function. Okay, so here's 3. So as x gets closer to 3, the function gets closer to 3 from below. As x gets closer to 3 from above, the function gets closer to 5. Because these numbers are different, there is no limit. Okay, because there's that jump in the function. So down here there is no limit. The other question here that you should be able to do from now: what is the value of the function at -1? Is the function -1, is it there or there? What is the value? The value is -3. Okay, if you can do those, then you're half the way of passing this question. You get 2 more questions right, and you get a merit tick. Okay, so just going to pause the video. No, I'm going to stop the video there because it's long enough, and you can have a little look at that, and I'll make another one about continuity and differentiability and concavity. All right.